Today's lesson is going to be about interfaces. I know you guys probably haven't coded in a while, so we're going to practice coding. If you do not have JGrasp or a way of coding, then you need to download something onto your home computer so you can do this. I have included on Schoology the instructions of how to download JGrasp. Please let me know if you cannot do it. We'll have to figure out something. Maybe we could borrow a laptop from downtown. All right, so get in touch with me. My office hours are 9:30 to 11 a.m. every A-day. Feel free to Schoology me anytime, but if you Schoology me during that time between 9:30 and 11, I will respond to you almost immediately. All right, so let's get started. Interfaces. File, new, Java. Make sure your line numbers are on so we can all... All right, so we're going to do this interface, these programs, around geometric formulas and shapes. So I'm gonna type out the entire thing. This is gonna be pretty long, but we have all the time in the world. So, if I go too fast, just pause the program and catch up. Now let's talk about what is an interface. An interface is part of Java. It's a program that other program uses. It stores constants and a list of abstract methods that are defined in whatever other program uses the interface. And the one key thing is every abstract variable, abstract method that is defined in an interface must be defined in the program that uses that interface. Okay, so okay, the header of an interface is slightly different than a class. It's public interface. And I'm going to call it GeoConstants. So in here, in an interface, you can put constants. Now, the reason why an interface with constants is very useful is if you're doing programs that use a lot of constants, you don't have to reinstantiating them in every single program. You could put all your constants in this one interface, and then you could just call upon it using a regular program, and all those constants would be available to you no matter what. So this is the most useful feature of an interface. Public, final, double, I'm going to call this pi. Remember, the naming convention of a constant is all caps. I'm going to use 3.14. That's as far as I go. That is the end of our interface of constants. All right, so I'm going to compile this. It's going to want me to save it. I'm going to put it on my desktop. All right. All right, so there are my constants. This is an interface. Now inside of here, you can also have abstract methods. But I'm going to create a separate interface that has all the methods and show you how you can call upon more than one interface. All right. So File, New, Java. Now we're going to have, where are we? Okay. All right. The Geo Formulas program or interface demonstrates abstract methods. So once again, public interface Geo Formulas, open and close squiggle brackets. I know you really miss syntax errors. I know you do. So abstract methods. Now an abstract method is just made up of the header. All right, and it has to be public, otherwise you can't get at it. Public abstract double surface, if I can spell surface right, area, and you close it with a semicolon. Now, there's two words in here that are not necessary. They're redundant. Is the word public and abstract. If an abstract method denoted by the semicolon after the header is put into an interface, by default it is public and by default it's abstract. So I could do double surface area, and then in here I'm going to put double, if I can spell, radius. All right, so let's see if that one's okay. We're going to put it in the same place. Yep. Notice my line 10 is missing public and abstract because by default it doesn't need it. So we have two more that we want to do. We got double volume and we got double volume and double radius. So all four of these are abstract methods. Now these could have been put in this interface and then we'd have everything there. So you could actually have two sections of your interface, listing all your constants and then making a list of all your abstract methods. Now I think this feature of an interface doesn't add a lot of value to Java. I mean, so what? So what if you have a list of all the methods that different programs that interact with this interface define differently? Why do you have to have a list? I don't know. But they have set this up in Java, so I wanted to teach it to you. All right, so let's do our next. So we're going to create a sphere. We're going to use a sphere. So File, New, Java. All right. The sphere program demonstrates implementing an interface. So we start this like a normal class. Public, gotta spell public right, class sphere. Now, how you have access to an interface is with the important word, it's a reserved word called implements. See how it turned purple? And then you name off as many interfaces as you want. GeoFormulas, gotta spell it right, separated by a comma, and GeoConstants, open and close squiggle bracket. Now, a class can implement as many interfaces as you want. Now, in these formulas, you don't have to use any of the formulas if you don't want to. I mean, you can't. Constants, let's go back. Constants, you don't have to use any constants. But formulas, if you have a formula, which we have 4 of them here, surface area with no parameter, and surface area with 1 parameter, see these are overloaded, and volume with no parameter, and volume with a parameter, once again these are overloaded. You have to define all 4 of these in my sphere program. You have to define them. All right, so let's do some instance variables. So we got private double radius. Cool, all right. Now, do I have to define pi? No, I don't have to define pi because my implementation of the GeoConstants allows me access to that constant. All right, so now let's do some, we got a constructor. All right, so this is our default constructor. So public sphere and we're going to make radius. What should we make radius? Let's make radius 10, okay? Then we have our overloaded constructor. This radius, remember the word this. All right, so whatever we tell the radius is, this radius, which is the same as this radius, is put in the instance variable of our object, which is our instance variable. All right, so those are our 2 constructors. Now we're going to make some, now we have to define those 4 methods. Okay, so let's do public double surface area. Now I have to return a double, don't I? I have to return the double. So what we're going to do is our formula. So you could do a formula and assign it to a variable. You know, first declare the variable and then assign it the variable and then return the variable. Or you can do a single line. So I'm going to do return. Now, the area of a surface area is 4 times my constant from the interface times math.power, pow, and we want this radius, gotta spell radius right, comma, squared. And we're going to end it with a semicolon. All right, so when we invoke the surface area of a sphere, it's 4 pi over the square root of the radius squared. Now what we want to do is we want to do the overloaded one. Public public double, gotta spell double right, surface area double radius Alright, so return 4 times pi from an interface times math.pow radius squared. Okay, so let's compile and make sure we don't have any mistakes. Oop, guess I gotta save it. Geoformulas, sphere. Alright, so I'm going to pause this for a second and fix my problem. And then we'll pick up with part 2.